everyone, Assalamu alaikum. This is Jahania Shah, and today I'm very excited to present our project to you. So, a little about our team. Our team is D Musketeers, of course, one definitely. This team is comprised of myself, Jahania Shah, Ahmad Atif, Najib Jilani, and Muhammad Qasim Khan. Our project is about designing a digital hardware to play Chrome T-Rex Dino game using EMG module, which is electromyography. Before we jump into the project, I would like to share the various ideas our project have gone through, starting with our first idea, which was to make a simple ECG device, and by simple I mean measuring heart rate and pulse only. We studied various papers for this idea, but due to some significant gaps in our knowledge, such as signal processing, Fourier transformations, we had to subside this idea. The next idea which came to our mind had to make sure we incorporate some FSM, so opting for a game was a natural pick, but we wanted to bring some cool twist to it. So we decided to make T-Rex game which takes input from the human muscles. The game mechanism is very simple. It is a standard Chrome Dino game. It has a start screen, running state, that is when jump button is not pressed, jumping state when jump button is pressed, and a collision state when game detects a collision and subsequently move the game state to game over screen. That was a very general and high level overview. On implementation, this FSM includes the most of the game mechanisms. But there are 5 states in which idle is the default state at which the game is stuck. Once we give it 1-bit input through a keyboard or EMG module, it starts running. There is another inner FSM, which is jump FSM. It works on some conditions. Once the moving dino collides with the obstacle, the game leads to that state. It goes back to ideal state once we enter the input of 1 bit through keyboard. As a part of our project rubrics, we have to use VGA based display as our primary display. The mechanism of VGA monitor is little tricky for us to learn at first, but when we grasped it, adding some nice or crispy graphics was a joy. Although, admittedly, it is rushes as of now, but we will share some info on it with our plan with this Project Till DLD exhibition. So this is the overall schematic for our design. It has clock division, which is C1, which is the clock divider, which basically slow down the clock from native 100 megahertz to 25 megahertz. Okay, so this is a score counter FSM. This is not behavioral as before. We have talked about the main FSM game, but this is the gate level FSM. This means the whole FSM, which comprises of 3 states: idle, run, and end, along with 2 inputs: enter, or we can say the jump button, or game over flag. Idle here means the score counter is on default reset state, whereas run state is when a score counter will be incrementing with the passage of game, and is a pausing of the score counter once the player has collided and game is over. You can also see the circuit diagrams by which the FSM has been implemented. Now we'll be talking about some brief technical overview. Now we can move towards its application and at least some of its potential application. For example, it can be used in physiotherapy of patients as they recover from injuries, while interactive monitoring of patients' muscle recovery. It can also be used to enhance VR experiences and make VR more immersive. Well, this concludes our demonstration, but there are some things we would like to touch upon, namely the prospect of this project and certain realizations we have learned in regard to importance of digital logic and design. We have planned for this project till planned exhibitions. We plan to improve the graphics of the game. I know that's not better enough. We'll remove the bugs and incorporate the EMG input into this project. We are also looking forward to the exhibitions. As for the importance of digital logic and design, I think this meme says it all. Yeah, I would say thank you so much.